And we have today's lecture, and then we've got Thursday where I'll be doing kind of a review. Um, I'm going to begin working on your exam as well as the practice exam. Um, and I will post the practice exam before our next class meeting. Um, and so you'll have that available to study off of. But in the meantime, just kind of you've got
Are
all
you still on there?
oh, you've got all the documents that you've that we're going to be covering on this exam, all the PowerPoints and everything like that. Now, with that, we're going to be talking about magnesium and zinc. And, the idea here is that we're talking in general about like kind of health. We've talked about cancers and how they can develop, as well as we've talked about chemotherapies. And now we're going to talk a little bit about minerals and vitamins. Last time we had a lecture on iron and its role in kind of bodily functions and its role in your everyday life, as well as the amounts that you need. Today, we're going to get into magnesium and zinc. And I think that, most people have you know, let me share my experience with magnesium and zinc. I've always heard people take magnesium for the purposes of, maybe if it's like if they have trouble sleeping or migraines. Sometimes they'll take magnesium. Zinc, I know that some people will take it because, if they feel a cold coming on or something like that, they're going to take a little bit of zinc as well as vitamin C or something like that, in order to kind of keep that cold at bay as best as possible. And so today we're going to kind of talk about, the efficacy, the kind of efficiency or the purpose of that. And I'll share with you guys some screenshots of primary literature, scientific literature that supports taking one of those supplements. So first and foremost, we're going to talk about magnesium. Now, magnesium is involved in more than 300 different biochemical reactions. And some good dietary sources of magnesium outside of like a supplement, good dietary sources would be spinach, nuts, um, seeds, as well as whole grains. A recommended daily amount, or your RDA, for magnesium is approximately 300 to 400 milligrams per day. Now, here what we have is a table that shows different food sources and then the amount of magnesium, the number of milligrams of magnesium per 100 grams. Okay. Now, this might, think back to 1310 when you talked about units. So this is a gram is a typical mass unit. And in 1310, we also talk about prefixes. Um, and I want to go ahead and highlight a pair of these. So 270, if you get 100 grams of almonds, you're going to get approximately 270 milligrams of magnesium. Now, that's a biologically relevant form of magnesium. Um, and so with that amount, I think that it's useful to think about these units here, prefixes and grams versus milligrams. Well, one thing to keep in mind is that 1 gram is equal to 1,000 milligrams. And my eyes are kind of pointing it over here just because that's where my tablet works and everything on this other screen that I have. So 1 gram is 1,000 milligrams. I bring that up just because if you see per 100 grams, 270, um, that might seem like, oh, that's backwards, that's broken, that's off. It's not. Don't worry. This all boils down to that prefix. So milligrams. So this would be the same as 270 milligrams would be the same as 0.270 grams. So if you consume 100 grams, I'm sorry, of almonds or 100 grams of pumpkin seeds, you're going to get 0.270 grams and 0.535 grams per 100 grams. So essentially what that means is if you need magnesium, it's a good idea to, well, consume a bunch of pumpkin seeds. Now, for the things that magnesium is involved in, well, it is a cofactor in ATP production. Now, ATP is what many people refer to it as is kind of the cells possessive um, energy currency. And so, if you think about a sugar like glucose or fructose, whatever sugar that you're thinking about, well, sugars are broken down, and the way that they're broken down is, or the process by which they're broken down is to make ATP. So anytime you talk about like, eating a steak or eating a candy bar or something like that, your body's primary function, or one of your body's primary functions, is to make this compound right here. This compound right here is known as ATP, or adenosine triphosphate. Now, magnesium is a really important compound when it comes to adenosine triphosphate. And the way that it plays a role in um, the function of adenosine triphosphate, or ATP, is by, notice here, magnesium is what's known as a divalent cation. And effectively what that means is that it has a two, hence divalent positive, meaning a cation. So it's a divalent cation. And what it's going to do is it stabilizes these negative charges right here. So magnesium as a divalent cation stabilizes negatively charged, or negative, I'll say negative charges on ATP. And so it's almost like if magnesium's not there, that ATP molecule, those negatively charged groups, well, they're not stable. They're not in the right position. So that ATP is a little bit less useful. So what magnesium does is it almost makes, I guess you could say that it makes ATP more kind of, I would just say, useful, for lack of a better word. Now, with that in mind, that's kind of the mechanistic role that magnesium plays. Now, to speak kind of generally, and the role of magnesium is it's involved in glycolysis. That is this process right here, the breakdown of sugars. It's also involved in a process known as oxidative phosphorylation, or for short, OXPHOS. And this is, I always kind of think about glycolysis as like the initial breakdown, but this is the total and the final breakdown of sugars. So glycolysis and oxidative phosphorylation, or OXPHOS, these take glucose and basically break it down into six CO2 molecules. So it's going to break things down into that. Now, it's involved in other energy pathways. Now, what I want you to know for this slide, and for this with respect to what's the role of ATP, I want you to know that it is the cell's energy currency. In addition to that, it stabilizes negative charges of ATP. So I want you to know that those are the kind of functions and those are the roles that magnesium plays on a like very practical action. This is specifically what it's doing. Now, most of the things when it comes to things, or most of the processes that relate to the function of magnesium and the role that magnesium plays, they're a little bit more general. And so here we see that an example of that. Magnesium in muscle and nerve functions. Okay, well, magnesium supports muscle relaxation and nerve function. And the way that it does it is by regulating the balance of calcium in a muscle cell by regulating these molecules known as calcium channels. So if you imagine that every cell within your body, specifically, let's think about muscle cells, they have the ability to let minerals like calcium in and let calcium out. In magnesium, what it's going to do is it's going to help maintain the right amount of calcium present. So think about this as the role that magnesium plays is it controls and I would say ensures the right amount of calcium. And I'm going to just label calcium as Ca2 plus because calcium is also a divalent cation. The right amount of calcium inside muscle cells. Okay. Now, in the same way, it's going to regulate neurotransmitters by controlling calcium flow into nerve cells. So think about this right here, this statement right here. What magnesium does, and actually I'm going to cut that off. I'm going to narrow it a little bit and say that magnesium controls and ensures the right amount of calcium inside of, and after inside, you can either put in there muscle cells or nerve cells. Now, what does that look like? What is that? How is that relevant and what's significant about that? Well, let me ask you a little bit of a kind of broad question. Does anyone know of, and you can add to the chat, um, does anyone know of any neurotransmitters? And these are kind of like, think about them as compounds that make you feel specific ways. I'll give you a hint of one that I can think of. It starts with a D, and it's something that it's kind of like if anyone has attention deficit or ADHD, it's kind of like your brain is constantly seeking it out. I'll give you a second to think on that. Well, the compound that I'm thinking about and trying to suggest is known as dopamine. Dopamine is an example of a neurotransmitter. Another example of a neurotransmitter would be something like serotonin. It's a compound that nerve cells communicate with and are used to communicate, and we see them sort of as like molecules that almost make us feel certain ways. So serotonin and dopamine are both neurotransmitters. And so magnesium plays a role in basically the release and control and the regulation of those. Now, another thing, and maybe more relevant to some folks, is that what magnesium does when it comes to nerve or to muscle cells is, oh, not there, highlighter, is it prevents cramping and muscle spasms. So if you go out for a long run or something like that and you start sweating a lot, what's going to happen is your body's going to lose a bunch of nutrients. You're going to lose salts. Sodium's going to be kind of flushed from your muscles and calcium might be too. And so what some people will do in response to that is they'll take a magnesium supplement. Alternatively, sometimes people will use a lotion with magnesium on it because then you can potentially get magnesium from that lotion as it's applied to your muscles to prevent cramping. Now, magnesium also plays a role in cardiovascular health. It helps to regulate blood pressure by relaxing blood vessels. And it's found to reduce blood pressure in kind of this, what's known as a meta-analysis. So a meta-analysis is where somebody basically analyzes a bunch of different papers, a bunch of different studies, and they kind of draw a conclusion. Now, it is going to reduce the risk of hypertension and cardiovascular disease. And one of the ways that it does so is it comes back to those calcium channels. So if you're thinking right now, like, oh, what's something that I need to know about magnesium? Well, magnesium influences and impacts calcium or Ca, I'm going to say Ca2 plus channel function. And really, the main point of magnesium and the main role that magnesium is going to play is it's going to kind of maintain, I guess you could say, magnesium helps maintain Ca2 plus, I'm going to say homeostasis. Basically, it helps your your cells maintain the right amount of calcium inside and outside of them. Okay. So to kind of rehash, well, magnesium is going to play a role in making ATP work for your body. In addition to that, it's going to help maintain calcium levels in and outside of your cells. And that's going to, prevent cramping from occurring as well as muscle spasms. Now, what magnesium also plays a role in, and this is an example of one of those different biochemical reactions, is that magnesium helps in bone formation and maintaining bone density. So if you ever look at or if you look at like a cross section of a bone, it's actually kind of it looks kind of porous, and so it's got a bunch of holes in it. And if you've ever heard of, does anyone know of that? I guess you could say a disease that generally it's people who are advanced in age or at an advanced age that it kind of accumulates or becomes an issue. But it's basically where your bones have kind of larger holes. Does anyone know what that disease is called? I'll give you a hint. Close, close. Arthritis is where like your joints become problematic. But I'll give you a hint of the kind of prefix word, osteo. Have you ever heard of osteoporosis? That's the disease where basically your bones, the holes that are in your bones get larger and larger and larger. And your bone density therefore goes way down. So magnesium is a mineral that helps bone formation and helps maintain bone density because you want your bones to be like strong and you don't want them to break easily. If somebody has osteoporosis, well, then their bones break very easily, or they have more of a tendency to break easily. Now, what magnesium can also do is it works alongside calcium, as we've kind of rehashed or we've kind of discussed, but also vitamin D for optimal bone health. Now, vitamin D is something that typically, if someone says, "Oh, I have a vitamin D deficiency," I think the easiest recommendation for them is to, walk outside and expose themselves to the sun. Um, and so, um, what that is typically going to display, or sorry, what that is relevant for is sunlight exposure is a way that your body can make vitamin D. Now, in addition to that, there's a couple of steps that basically kind of make a bioactive form of vitamin D. And those are, there's an enzyme known as 25 hydroxylase and another enzyme known as 1 alpha hydroxylase. So what we've got here is 25 hydroxylase and 1 alpha hydroxylase. So magnesium is pretty important for making, and this right here is the active form of vitamin D right here, this 125OH2D. So vitamin D3, the type of vitamin, actually what I have right here. bottle of vitamin D3, I'll take this as a nutritional supplement or a dietary supplement if I don't get enough sunlight exposure. But then I've got to also have magnesium to help out making that vitamin D3 fully active. Um, in addition to that, well, these enzymes, well, this one, 25 hydroxylase, it needs magnesium. And you can kind of see it in the background here. I'm going to shade it in. I'm going to shade in this kind of black amorphous blob. Um, this is to represent the organ in your body that has this 25 hydroxylase. And this is in the liver. And the other enzyme, this 1 alpha hydroxylase, that's in the kidneys. So what I want you to take away from this is that magnesium helps get the fully active form of vitamin D. So it helps take the vitamin D3 that you take or that you get in your body. Um, and these two enzymes help kind of finish the action of getting it ready to go. But what I want you guys to take away from this is that magnesium helps out with that. So, and I bring this up because we will talk about vitamin C and other vitamins, and vitamin D is the one that magnesium helps form. Now, deficiencies of vitamin D. Well, it's a phenomenon known as, or a disorder known as hypomagnesemia. Magnesemia. There we go. Magnesemia. There we go. Okay. And this is basically just that you have a deficiency of this vitamin or this mineral. And what it can lead to is muscle cramps. It can lead to fatigue. You might just feel kind of tired, irritability, as well as abnormal heart rhythms. Because remember, this all has to do with basically how your muscles work. And is your heart is a muscle. And if your heart is kind of acting in a way that it shouldn't, then you're going to kind of recognize a problem. Now, some at-risk groups for this are elderly folks, athletes, and those with any sort of digestive disorders. So, what I want you to know about this is that a magnesium deficiency can lead to or manifest itself and show these different symptoms there. That's what I want you to know about this. Now, here's some more details on it and in terms of the population of the United States, a small percentage can be afflicted by this. But if you're already facing some sort of health issue and you're in the hospital or in the intensive care unit, or you have alcohol use disorder, you're more likely to experience this. Now, one thing that you can do is obviously if we jump back, if you have a deficiency in magnesium, one thing that you can do is just, well, go start eating pumpkin seeds and eat them 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 and eat them. And you're good. Alternatively, you could use a magnesium supplement. And sometimes these are recommended for anxiety or migraines to get better sleep as well as improve energy. Now, the magnesium supplements are going to show in a couple of different ways. There's magnesium citrate, there's magnesium oxide, and then there's one also known as magnesium glycinate. Okay, now the differences between these. They're all your divalent cation. What I want you to know about these is basically their absorption rate. Magnesium citrate ranges from about 20 to 50% of that. And what that means is you could kind of think about it as the useful amount. So let's say that you took 100, or no, let's go with a 1,000 milligram magnesium supplement. And so I'm going to scribble this out. So you had 1,000 milligrams of magnesium citrate, and let's say there was 50% absorbed. Add to the chat what amount, not percentage, but what amount of that basically passes straight through your body and you don't get any benefit from it. What amount? If it's 50% absorbed, what amount goes straight through your body and doesn't do anything? Perfect. 500 milligrams. That's absolutely right. So 500 milligrams are going straight through your body and you don't benefit from them. Okay. Now, I want you to remember the absorption rates of all of these different supplements. So 20 to 50%. And a test question would give you a range of that. Would say 20 to 50% is the range. Magnesium oxide, oof, 4 to 5%. Wow. So that's an instance where basically a huge amount of it is going straight through your system. Your body's just saying, okay, cool, done. I don't need it. Um, so like 95 to 96% is going to go straight through you. Now, some of the disadvantages or cons of this, and again, I want you to know the absorption rate. Some of the disadvantages or cons or are that it can cause dehydration. It can cause diarrhea. Now, benefits of it, well, it's cheap. It can relieve heartburn. It can also relieve indigestion. So there are some benefits, but there are also some risks and disadvantages. Now, magnesium glycinate, that's one that from from my own personal experience, that's the one that has been recommended in the event that you have like if you have trouble sleeping. And that is a magnesium supplement that is 80 to 90% absorbed. So as soon as you ingest that, most of that gets kind of sucked up by your body. It's typically easy on your stomach and it kind of has a calming effect. Some of the disadvantages are that it's expensive and it can cause sleepiness or drowsiness, another way of putting that. Okay, so what we've looked at so far is we've talked about the RDA, which if you remember the RDA, that's about 300 to 400 milligrams of magnesium a day. We looked at some sources, so some food sources of magnesium, SOURCES, good. And then we looked at basically its role and kind of its how it can positively benefit you. And then last but not least, we talked about supplements. We looked at three of them and, the percentage absorbed. So our three different supplements are magnesium citrate, which is at best 50% absorbed, magnesium oxide, which at best is 5% absorbed, and then magnesium glycinate, which is at best 90% absorbed, 80 to 90% of it. So what I want you to know about these different things, I'm not going to ask you a question about a source, but or a specific source, but instead what I want you to know about is the RDA. And on a test question, I might give you a question, or sorry, on the test, I might give you a question where I say, hey, you have eaten 100 grams of this food. And from 100 grams of this, do you get the RDA or are you within the RDA amount of magnesium? And so I'll, reference or I'll provide you with here is the food source and here is the amount per 100 grams. And so it's up to you to look at that and say, yes, that does work. So if I were to, present that as a question, it would be something like, um, so you'd have to recall the RDA, but I would say something like you eat 100 grams of cashews and nothing else. Did you get enough magnesium to kind of satisfy your body's RDA? And I'll pose that question to the chat while I drink some water. So if you eat 100 grams of cashews, you're going to get 260 milligrams of magnesium. And so would you have gotten your RDA of magnesium for the day? Nope, you wouldn't. You'd be below that. In which case, then if that's all that you ate over the course of the day, then you might or you might be more likely to get some muscle cramps or be tired or irritable. Maybe that's my reason. Hmm, I don't know. I think I get enough magnesium. I'm not sure. Okay. So those are kind of the things that I want you to know about. Now, the RDA is basically your recommended daily amount. It's not necessarily the minimum amount. Um, it's not like if you get less than this, you're going to, die or anything like that, but you might have some symptoms. Or there might be something that appears and, you might be tired or something like that. Now, your RDA is kind of that minimum range or the ideal range. Let me rephrase that. The ideal range, the ideal amount of magnesium. But there's also an upper limit or an excess magnesium. Now, this excess is going to fall into two different categories. One category would be kind of a mild. So let's say that, um, so it's mild versus severe. And a severe amount or a severe excess would be basically where you're taking way too much every single day. Now, I bring this up over here, LD50. Now, does anyone know what LD50 means? And I'll give you a hint. Typically, whenever an LD50 is measured, it's related to rats or mice. Does anyone know what an LD50 is? So an LD50, L, I'll give you that, and then let's see if we can come up with the D. This is lethal. And then D for dose. So the lethal dose. An LD50 is a lethal dose, and the 50 is 50%. So an LD50 is, let's say that you had 100 rats and you give all these rats this particular, or you give them magnesium. And I'm not exactly sure how this is done, um, but you like how the study would be executed. But effectively, what you're looking at is what amount of magnesium kills 50% of the rats. And the answer to that is, well, between 3990 milligrams per kilogram and 3870 milligrams per kilogram. So effectively, what that means is that if you have, let's say, 3.9, I'm going to just give a nice round number there, 3.9 grams per 1 kilogram, 3.9 grams of magnesium per kilogram of body weight of those rats. And the idea here is it's like trying to figure out, or an LD50 gives you a sense of a unsafe, an unhealthy, oh, gotta rewrite that, a amount of magnesium. And an LD50 is not simply for measuring the kind of amounts that are hazardous for magnesium. Instead, it's basically anything. Anything has an LD50. How much of this is going to harm 50% of the population? Now, if you were to look at a person, 3.9 grams, and let's say that a person is 70 kilograms, that would be approximately 280 grams. That's a ton. That is a huge, not an actual ton, but that's a large amount of magnesium that you'd have to take. That's not to say the LD50 is not the upper limit, um, but instead it's just an absolutely unhealthy amount. Um, Now, with that said, let's go ahead and look at zinc. Now, zinc is an essential nutrient or mineral for immune function and DNA synthesis. The RDA is 8 to 11 milligrams per day. Now, if you think about zinc and magnesium and their differences, well, one thing that should tell you is that magnesium is used a lot more throughout the body because you need a lot more of it. 8 to 11 milligrams. And then if you look at this, we've got different demographics. Um, and the amount that different populations or parts of these demographics need is going to vary a bit. Now, but the good range is basically, or a kind of safe range is 8 to 11 milligrams. Now, if we look at different food sources, again, this is content per 100 grams. I'm not going to ask you these specific numbers, but I'll ask you a question about like how much of, you know, how many grams of almonds do you need? Again, almonds, do you need to get all of the zinc that your body needs? Well, if we're looking at 8 to 11 milligrams, um, 3.3, well, if we did 2 times 2, that would be 6.6. That wouldn't get us within the healthy range. So instead, let's say if we multiply this by 3, that would get us to about 9.9 milligrams of zinc. So what that means is that we're talking about 100 grams times 3, which would be 300 grams of almonds is what you would need to eat in order to get within that range. Oysters, well, 32 milligrams is what you would get from 100 grams of oysters. So just something to think about with respect to kind of the scaling. Now, with that, what does zinc do? Well, zinc plays a role in your immune system. It's necessary for development and maturation of T cells, and deficiencies can lead to the shrinking of your thymus. Necessary for cytokine development, and it helps for or it benefits, or it helps in the production of pro-inflammatory cytokines. So cytokines are molecules that basically are going to help fend off a disease and help you kind of combat diseases. So when you have the appropriate amount of zinc, I want to highlight this right here. Um, your body is going to balance immune cell numbers and functions. It's also going to balance between tolerance and defense mechanisms. So this is where your zinc homeostasis is going to be. It's going to give you a balance between numbers and functions of zinc. Now, in terms of what else zinc is going to be capable of, well, zinc is involved in DNA synthesis. And there's kind of a trend between um, as you age and zinc within your body and how that impacts you. So here's a paper, here's a peer-reviewed journal article that says the impact of zinc on DNA integrity and age-related inflammation. Now, what this, or part of what this paper goes on to say is that zinc deficiency has a global impact on health among susceptible populations. So like elderly people are more likely to have a zinc deficiency. Approximately 12% of the population are not consuming enough zinc in the United States. And that number increases to more than 40% in elderly populations. So as you get older, you and your peers are much more likely to have a zinc deficiency. Now, the consequences of cellular zinc deficiency have an impact on oxidative stress, DNA damage, and immune function. Now, this is all, or the kind of point of all of this is if you look at this right here, what this is showing is this is kind of an interesting graph. Well, what I want to draw your attention to first is the top of it, where it shows our arrow moving to the right. And that's indicating that this number is increasing. So age increases, okay, as we move from the left to the right. And then what this little triangle and what are all these, I want to bring your attention to this triangle at the bottom. And notice how it starts out very small on this side, and then it is considerably larger on this side. What that's showing is that this becomes an increasing problem as we move from the left to the right. So this is increasing chronic inflammation. This is basically where you kind of feel or there's lots of inflammation in your body um, almost all the time. And what that aligns with is over here, declining zinc status. And so this is where your zinc or the amount of zinc within your cells is declining as you move from the left to the right. So as you get older, you're more than likely to have a zinc deficiency. And lo and behold, as you get older, you're also more likely to have increasing chronic inflammation. So these two things, it's not necessarily a cause and effect, but it's entirely possible that they are related to one another. Now, zinc is an enzyme cofactor. What that means is that all of these different items right here, these are enzymes. What that means is an enzyme is a protein that does something. We've talked about enzymes a little bit previously, and zinc is basically helping those enzymes. Now, if we look at a couple of them, let's just go ahead and pick out this one right here, this one right here, and then let's go with this one right here. Let's look at the top three. Okay, our first enzyme is an enzyme known as carbonic anhydrase. What carbonic anhydrase does, I'm going to switch to my highlighter, is it catalyzes the conversion of carbon dioxide and water into bicarbonate. Okay, now those most of those, or at least two of those three are terms that you're familiar with. Carbon dioxide, okay, got it. Water, got it. Bicarbonate. Okay. Now, what I want you to know about that is that this is basically how your body expels CO2. So your body transfer the protein hemoglobin moves oxygen throughout your body. And as it moves oxygen throughout your body, then that gives all of your different cells, your muscle cells, and every cell the ability to break down sugars and make carbon dioxide. Okay, so when you move oxygen to your cells, that gives a way for your body to produce a bunch of carbon dioxide. Now, when you exhale like that, like I just did, my body produced carbon dioxide. Now, when my body produced that carbon dioxide, um, that exhaled CO2, think about that as originating in my cells, but then it has to get through my bloodstream. And the way that it gets through my bloodstream is by being converted to bicarbonate. And this enzyme, you could kind of think about carbonic anhydrase as the enzyme that gets CO2 out. I'm going to draw an arrow for out. So this is an essential enzyme. Now, zinc helps out with that. So in the absence of zinc, this is something that's going to be compromised. In the absence of zinc, your ability to exhale and get rid of CO2 is going to be undermined, okay, or at least partially inhibited. Now, another enzyme, carbonic anhydrase, ADH, or sorry, alcohol dehydrogenase, ADH. Now, this is an enzyme that converts alcohols to aldehydes and ketones. This is critical in alcohol metabolism in the liver. So whenever you drink a beer or something like that, well, what your body is going to do is it's going to take that alcohol is known as ethanol, and it's got to convert it. It's got to metabolize it. And zinc helps out with this metabolism of alcohol in the liver. Next and last is DNA polymerase. DNA polymerase is an enzyme that's involved in and essential for DNA replication and synthesizing new DNA strands by adding nucleotides to a DNA template. So DNA polymerase is essential for that process. And so what we have here is you could kind of think about it as zinc helps getting CO2 out. Zinc helps with, I'm going to draw a little line to give myself a divider here. Zinc helps with getting rid of alcohol. And then last but not least, zinc helps out with making DNA. And DNA is an essential molecule for, your cells to continue living and for you to continue living. Okay, so those are three instances or three things that I want you to know zinc helps out with. Those three enzymes, DNA polymerase, alcohol dehydrogenase, and carbonic anhydrase. Basically be able to name, if I gave you a question, which of the following is not, or sorry, which of the following is zinc not a cofactor? In which case, I'd give you like carbonic anhydrase, alcohol dehydrogenase, DNA polymerase, and um,
I will come to that meeting.
alpha calcitrase. Just make something up as the last one. So I want you to know those three. Next up, zinc is also involved in hormone regulation, hormone balance. For instance, insulin, the hormone that helps out with regulating blood sugar levels. Zinc stabilizes insulin hexamers. I don't want you to worry too much about that, but that's the structure in which insulin is kind of functional. Stabilizes insulin hexamers in pancreatic beta cells, allowing for the proper insulin storage and release. Okay, so takeaway from here is that, without zinc, insulin can't be stored well. I'm going to say stored or released. Let me erase that. Released well. Okay. Then let's also look at cortisol, another hormone. So these are the two hormones that I want you to know about, insulin and cortisol. Zinc helps regulate cortisol levels, reducing excessive stress responses and inflammation. So it helps out with basically making your body not be hyper stressed and in a highly inflamed state. Now, zinc deficiencies, okay, well, some groups that are more than likely to be deficient in zinc would be vegetarians as well as people with GI issues. So people who, it's almost like the food goes into their gut and it moves through it pretty rapidly to the point that your body doesn't have the time to absorb it. And some of the risks of this or some of the potential hazards and problems, you can have a weakened immune system. You can have hair loss, diarrhea, loss of taste and smell. And I'm going to go ahead and leave those four as potential risks of deficiencies. Weakened immune system, hair loss, diarrhea, and loss of taste or smell. Now, when it comes to zinc as a supplement, there's a couple of different supplements out there that are common. And I'm going to go through those. There's zinc gluconate, which again has our absorption rate of 20 to 40%. Zinc citrate, 30 to 40% absorbed. And zinc picolinate, that has an absorption rate of about 50%. So when you compare these, essentially what this boils down to is, well, if you could kind of look at it as which of our different zinc supplements, gluconate, citrate, and picolinate, which of these is most likely to see or to lead to most zinc waste? Okay, so if you think about it as which one of them is most likely to lead to zinc waste? Okay, well, picolinate at most 50% of your zinc is wasted. Citrate at most 70% of what's brought into your body is lost as a waste product or wasted. Gluconate at most 80% of it is lost. So to that question, which one of them is most likely to lead to a high percentage of waste? It would be gluconate. So I want you to know these absorption rates. I want you to know those ranges, 20 to 40 for gluconate, 30 to 40 for citrate, and 50 for picolinate. Now, just as zinc has a um, RDA, which the RDA for this was 8 to 11 milligrams. There is also the risk of taking excess zinc. It can interfere, for starters, with copper absorption. So any processes that your body needs copper for, zinc can interfere with the that copper being taken up, in which case then you're kind of in trouble with copper related reactions. Now, it can lower your what's known as your good cholesterol, your HDL. It can cause liver damage and it can result in anemia. Now, anemia, that's the state that your body can be in when you don't have enough iron. Zinc can basically outcompete with that iron. So, zinc can cause problems for copper as well as iron. So, I bring all these points up because excess zinc, excess iron, excess magnesium, every different um, kind of supplement or every different thing that you basically put in your body can, you can benefit from it, but there's a balance that you need to have. Um, Excuse me, if you take too much of something, then, or you might think like, oh, I need zinc because I'm feeling like a cold coming on or something like that. Well, if you take too much of it, that can be problematic because yeah, you might be able to fend off the cold, but then it might cause you to get really, it could cause damage to your liver. It could cause anemia to, you to experience anemia. Um, so, when it comes to supplements and supplemental substances, it's almost like, well, you don't want to supplement too much. It's almost like the best solution is to just have a very well-rounded diet and, get it from your diet. However, you know, if we go back here, if your diet is, to eat 5 pounds of oysters a day, well, then you're probably going to get too much zinc. Even 100 grams of oysters can present a little bit of a problem. Okay, well, that's what I wanted to go through today. On Thursday, we're going to be reviewing for the exam. I'll be working on your practice exam and hopefully have that up, or I'll have that up by the time that we meet next, or by the time that we meet on Thursday. I'm going to go ahead and stop my recording, but I'd like to